Cool. Hey everyone, thanks so much for joining. We'll get started here. As was just said, the talk title is Self-Discovering API Key Permissions and Resources, and we will dive way deep into what that means. And hold on one quick second. Somebody, oh man, another hard-coded API key. And it's this guy Dylan again, and a stripe key. And this is it's definitely a live key. Hold on, let me just send Dylan a quick message. Hey Dylan, this is the second time this week you've hard-coded this key. It's a stripe key. What's our exposure look like here?
Oh my God, this Joe guy bothering me again. I'm just trying to get my sprint work done. This guy from the security team just keeps bothering me.
What is he? When am I gonna get this guy off my back? It's like an old key. Joe, can you just cut me a break?
The fact that it's old makes, why does he even, this guy, I can't deal with him. Okay, the key is definitely live. I know for a fact it's positive. Can you please tell me what it can access? I need to know what our risk is here.
He's not gonna leave me alone, is he? All right, well, I don't even think this is my key, to be honest. I think it was Carol was the one who made it originally. I guess maybe I could tell him to go poke Carol.
Who is Carol? I don't think Carol even works here. I don't know what to do with this guy. Okay.
Let me see. Carol. Carol says it's a test key. All right, Joe, it's just a test key. It's not a big deal.
Let's see. Stripe docs real quick. I'm pretty sure if there's live in the name that it's a live key. Yes, there's tests and live keys. Everybody knows that. That one definitely had live in the name of it. Let me just double check. Scroll down a little bit. Yeah, test keys definitely have the word test in it. Ours had live. Dylan, this is a live key. I'm positive. It has live in the name of it, and it can access production data. Please let me know, can you please ask Carol to revoke this key?
Is it just Joe's full-time job to slow me down? Is that what this is? Let me go ping Carol. Let's see. She's really confident that even though it says live, it's just to her test account. There's nothing sensitive in it.
Okay. All right, please welcome Dylan on the stage too. Obviously that wasn't a real scenario, but that really does play out. Maybe some of you have experienced something similar to that. But the fact is there are lots of keys that don't end up getting revoked. And we wanted to study this. So last year we looked at 10,000 publicly exposed API keys on GitHub, and we tracked them for a month. And on day 0, they were notified that they had leaked their key. And we looked over time to see when the keys might have been revoked. And you can see in the first week, so time is on the bottom there, by day 7, there was a good chunk of them that had been revoked, but by the end of the month, there was still about 74% of these exposed keys were still live. Think about that, 74% is an incredibly high number of keys that are still valid after 30 days being publicly exposed and having been notified that they were exposed.
Yeah, so think about some of the different reasons why you might poke somebody and say, hey, you leaked a key out, and they don't actually go and revoke that key. One of them is, are you poking the right person, right? Go back to the beginning of that presentation. You had 2 different people at play. You had myself and Carol. Carol was the one who created the key. I physically couldn't even log into that account if I wanted to. Look at this string. It says the word live in it. Can I tell anything about this, about whether or not this is actually a live key, what permissions it has, what account it has access to? No is the answer. Statically, this type of vulnerability, you cannot get the answer. The only way to get the answer is dynamically. You have to send API calls. You have to actually be able to know the full story of that key beyond just looking at it. And with that comes a set of questions like, whose key is it in the first place? So imagine how many developers have a bunch of people on their team and they're all toting around the same environment variable file. One of them might leak it out, but they're not necessarily the person who put all the keys in that file. And so in this case, we had Carol who created the key and shared it with me, and then I was the klutz who actually leaked it out. I can't go in and log into that Stripe account. Only Carol can. So that's why if you send me a notification asking me to revoke a key, you might be poking the wrong person. So, we need to be able to answer that question, whose key it is. And up until now, that's been a very hard problem to solve. The next question is like, what permissions does that key have? Of all the things that a key could do within Stripe, does it have read access? Does it have write access? This is all going to inform whether or not we actually need to action on this thing. In the skit, I was saying, oh, it's not that important. And then what's Joe to do but to take my word for it? Because Joe can't log into the account either. Only Carol can. And then the last one, a little bit subtly different here, this last question, what can it access? That's different from permissions because imagine a scenario where we have two Stripe accounts. The one that can access the Stripe account that has all the juicy, sensitive customer stuff, that's the one we care about. Carol's personal account, we don't really care as much about that. So knowing what permissions within the account is one thing, but then knowing which account is another thing. So these are two separate questions we need to be able to answer if we're actually going to make progress on this problem. Look at this wide spectrum of different keys that got paid out in bug bounty. Like, why is it that an exposed key can both be a low severity and also a critical severity? And the answer is what we just said, with the difference between a key that has no access and a key that has full access, or a key that can access an account that has customer data versus somebody's personal account. You cannot tell by just looking at it. I mean, this string could be a really sensitive thing, or it could be access to nothing. So, all right, Joe, these are the problems. Why is it we're not able to come up with the solution to this up until now? What's the big challenge preventing us from answering those questions?
Yeah, I mean, it's those three questions. It's an information issue. This is often looked at, like an exposed key is often looked at as a code security issue, but it's a lot more to that. It's an IAM issue. We need more information to be able to properly prioritize and also remediate exposed keys. And I think you can also boil that down a little bit more. And the reason this is such a big issue is there's two separate thoughts here. One, there's no global standard that if I build an API, it has to have this endpoint that says return whose key this is, what it can access, with what scopes or permissions. It doesn't exist. Some providers give you that, which is fantastic, and we'll show some examples. But there's a lot of providers that just don't. And is it their responsibility? Maybe, maybe not. Either way, we still have to deal with that issue. And the other thing is API keys by design typically, rarely, maybe never, give GUI access to the SaaS provider, right? So if there's an exposed GitHub token, I can't just log in and check what permissions there are. That's what I would do if it were my token, but oftentimes in security we're dealing with other people's tokens and security credentials.
All right, Joe, I feel like in security oftentimes people paint a very negative picture. You've articulated the problems really well, but what do we do about it? How do we fix this information asymmetry?
Yes, so a very leading question, thank you. So there's a tool that, when we'll cover this more toward the end, we're going to talk about methodology and the tool here, but there's an open source tool now called TruffleHog Analyze. If you have used TruffleHog before to detect and find secrets, this is a new submodule within TruffleHog. And this is a little preview of what it looks like. This is where we pass a GitHub personal access token in, and you can take a look at very quickly what permissions it has and on what objects, repos, do those permissions count.
Sounds pretty helpful.
Yeah.
But it also sounds like a really hard problem. Like, you have all these different providers and there's no standardization for endpoints that return the information. Like, how'd you actually go and build all this out?
So we're calling it self-discovery. I know that's used in other contexts too, but the whole idea here is we have this credential, right, this static string, and it's used to access API endpoints. It's the goal. Why don't we use some of those endpoints to self-discover some of the information that we need, the API key ownership information, the permission information, and the resources. So that's the whole idea there.
Okay, so maybe like a key can send API requests from itself to get the answers to those three questions.
That's it. It's like you already knew what we were going to cover.
All right. So let's start with that first question of who owns the key. Could you give us an example of self-discovery to get the answer to that?
Yes, so this first example is great. It's so easy. And having built the proof of concept for this tool, I loved seeing situations like this. There's an endpoint that you query. This is for Asana, where it's just /users/me, and it gives you the email address, the name, and a photo of the person. Yeah.
So when we track down Carol, we actually have her picture.
We now have Carol's photo.
This is going to be so easy.
Super easy,
All right.
except when it's not. Oh. So then there's Mailgun, which is a mail marketing service provider. They have an API, and if you ask GPT, you're like, hey, how do I get the email address or username of the key owner? it gives you this. It says there's no way to do it.
Well, wait a second. I mean, ChatGPT is not always right. You're not even using the latest fancy model that they have and stuff. Did you actually look in their API? Maybe there's a way.
There's not, well, there's kind of a way. And so this is like an example of some of the frustrations with just figuring out ownership information. So there's a /keys endpoint in the Mailgun API. And this, just so you know, well, I'm not calling out any specific provider saying they're doing something wrong. These are just examples of how their documents are.
Yeah, we'll tell you which ones do it wrong after if you come up to us.
So Mailgun has a /keys endpoint, and you can query for all the key data, which is great, and it gives like the key metadata, like who created the key, when, etc. The problem is it gives you all of the keys with the account. There's no way to associate the key that I'm requesting from is associated with the first response or the second or the third key. So we can have a set of people that have created keys at this company, but we don't know which particular person created that key.
Okay, so you find a Mailgun key somewhere, and basically you went from it could be anyone in the universe's key, 8 billion people, down to here's the people within the account that have made keys, but we don't know exactly which one it is. So you've narrowed it, but you haven't gotten the exact answer.
Exactly, and this is not uncommon. This type of situation plays out a lot with different API providers. So that's the first question kind of answered.
All right, what about the second question? What about permissions?
Yeah, this is where it gets real tricky. And I think when we were talking before this, I think you had the best explanation of fine-grained versus full access tokens. So I'll let Dylan explain this one.
Yeah, I mean, I just so many times I've seen companies as they scale to start out, they're like, we need an API, and they have one type of key that can access everything, right? And that gets them started, and then as their product matures and grows over time, they throw in more and more API endpoints, and people start asking for role-based access control and keys that can only do some things and not other things. And so then they make a second type of API key that has just access to like a certain fine-grained set of things. But the problem is they're never able to sunset the first kind of API key because so many people are using it and depending on it. GitHub's a great example. They've got their classic keys. And then they've got their fine-grained keys. And I have tried to use their fine-grained keys and many times gotten so confused by all the different buttons and knobs and stuff, I'll just fall back to classic. OpenAI is another great example where they've got their old type of key and their new type of key, and they're running both of them in parallel. And so now if you find an OpenAI key, you got to sort out which one it is. Is it fine-grained or is it the old type? So Joe, how is it that we're able to tell the difference?
Yeah, so this is a very clear example just to emphasize that point. Fine-grained on the left, full access on the right. There's other providers that just have full access keys, but it's not even just that. There is like more nuance and complication to this. It's like not even just like there's two types of API keys. And I just want to give a couple examples because it'll help understand a bit more about the challenges of enumerating permissions in a second. But MailChimp, many people have maybe heard of or used MailChimp. This is the screen that you fill out, the form, if you want to create an API key. There's just one box. So the assumption I had was that it was
full access, right? There's no fine-grained options.
But if you dig down in the docs a little deeper, it says it inherits the role of the user and their permissions. So it's not necessarily full access. Then you have SendGrid, which I think is a MailChimp competitor. They have full access and restricted access keys, but that doesn't include billing access for whatever reason. There's a billing access API key type. And so like there's just like webs of different types of access. And then GitHub, like you mentioned, there's two token types. I'm sure many of us in this room have created classic and fine-grained tokens on GitHub. I would even say they're both fine-grained tokens. You select which scopes each one has. The type difference is about what resources they can access. With the classic tokens, you get everything. So if you have repo read access, you get all the repos. With the fine-grained, you say repo read, but just these repos. So it's super complex. Like there's a lot of like things you have to dig into the docs to understand what's going on.
And I think it was pretty eye-opening when I looked at all the different repos I actually have access to, which is an exercise, you know, if you've been in the industry for 10 years, you should definitely do. And then I looked at every single classic personal access token I had could write to like 50 different code repositories, some of which go back decades. So I think that's why they made the fine grain, but it's just more difficult to use. So a lot of people, just myself included, sometimes fall back to classic. And this doesn't help us at all in trying to figure out permissions because we have to figure out which type it is first, right?
Yeah, so when we think about answering that second question of given this string, that's a credential, what permissions does it have? There's two steps. The first is we need to identify what type of key it is. That's why I went through that whole explanation of different key types. Because again, for each provider, it could be very different. And sometimes it's very obvious there's just one type of key that it could be, full access typically. Other times, like with GitHub, you need to actually look at server response headers to figure out what type of key it is. There's no endpoint you can query. You have to dig in a little bit in the weeds, and then sometimes you can actually just query the API and it will tell you. But that's the first step. The second step is then, once you know what type of key it is, you have to be able to enumerate the type of permissions that it actually has, right? So like, if you know the key type, it's like, this is the universe of permissions it has. Now, like, of that universe, what's the subset that it actually has? And in many cases, and this is an example from Open Weather, there's only one API key type. It gives you access to the entire API. Simple.
I'm guessing it's going to get harder.
It's definitely going to get harder. SendGrid is an example of like an intermediate difficulty. They have an endpoint that you can query that says /scopes that gives you the permissions that the key has. The problem is, this is the result. Unless you've like dug into SendGrid's documentation, and even so, that is hard to parse and figure out exactly like what, like, okay, it has sender verification eligible. Like, what does that mean? Like, what is the risk of that particular scope? If I'm triaging a bunch of issues at once, it's kind of a lot to ask somebody to dig in to understand it. For the tool we're open sourcing, what we tried to do from there is say, these are the scopes. Let's map them in a way in a nice table that kind of looks like the GUI that you would expect. So you could bring up the GUI and it would kind of match what the output would be.
I've never worked at SendGrid, but I know exactly how this must have happened, where they have a very intuitive GUI that shows the permissions, and then under the hood, they've got scopes that are banana crazies. Nobody can understand them. They hired a designer, and the designer's like, we're going to make the front end look really nice and intuitive, and the designer never went to the back end and never made the scopes cleaned up. And so now we're left with this kind of bifurcation. And so, Joe, it looks like that must have been a ton of work to be able to take their bananas back end and make it look like their front end.
It was, but again, this is not even that's not the hardest one. The hardest is situations where there is no endpoint, like literally doesn't exist, where you can query to get the permissions. It has not been built. And for that, we have to rely on brute forcing, which is, we use the name because it's similar in process to other cases when you'd brute force. But the idea here when I say brute forcing is, let's identify one permission that maps to one endpoint of the API that, based on the server response, we can know definitively whether that key has that permission or not. It is clearly binary. And so it's challenging for a few different reasons. One, just digging through the documentation is a lot of work. But second, it's really critical to put guardrails in place, especially for an open source tool like Trufflehog Analyze. It's extremely important to not change state when you're trying to check if it has a certain permission. So for that reason, we would prioritize things like GET requests. Although GET requests don't always not change state, sometimes they do. And so it's often important to dig into the docs and see if there is the potential to change state given an API call. How can we send a malformed request to prevent it?
Malformed request. Tell me a little bit about that. Like in an example where maybe all a key can do is upload a file.
Yes.
Like how are you able to figure out if that key can upload the file or not without actually uploading a file?
So let's say a file upload feature allows like TXT and PNG files. Maybe we would put a JPEG in there. So it's not allowed, and the server would be like, hey, you could do this if you did it right, but you didn't do it right, versus you definitely can't do this because you don't have access.
So you're sending something you know will never upload, but based on the error you get back, you can tell whether or not it has the permissions to upload?
Exactly.
That's clever.
And so just a very brief example here. This is from Stripe, from the situation earlier. There is a permission called balance read. Doesn't really matter, but I just want to walk through the exercise of how annoying this can be. You know it's balance read. You'd have to dig through the docs to figure out where the balance object is and try to figure out an endpoint that you can request to figure out if it has the read permissions. So in this case, there's a singular GET request. Then you make two keys, one that has the permission, one that doesn't have the permission, and look at the responses to see if they're different. In this case, it was very clear in the error message on the bottom right. It says balance read permission doesn't allow this, it doesn't have it. So that's the process. But then with Stripe, you have to do that 127 times.
127? Stripe has 127 different permissions?
Apparently.
I didn't know that. That's a lot of things you can do with Stripe.
It is a lot. And so, and that's a good point. Like if you are responsible for remediating an exposed key and it's a restricted access token or fine-grained token in Stripe's terms, how could we expect anybody to go through that exercise and do that 100, it took me 3 days to do that. Like, we can't expect anybody to do that. It takes too much effort. And so then we fall back on Stripe is a financial company. It's probably bad. Let's remediate it. But what if it's a test account? You know, like there's a lot of questions that we still need to unearth in order to be able to prioritize and understand the risk of an exposed key.
Okay, so we talked about permissions, we talked about whose key it is. What about that other question, like the which Stripe account it is, or like what underlying resource do those permissions actually apply to?
Yeah, so I like to think of this question as like, what can it access? So by resources, I just mean, pretend you're an attacker or an engineer. What do you want to get using the API? That's all. And so I think a clear example is for GitHub, that'd be repos. There's other things, of course, but that's like a nice baseline. For SendGrid or MailChimp, this is maybe a little like more tricky to kind of wrap your head around, because like maybe you could say the contact list of the users that are in there, but I would say what's most valuable.
What is SendGrid? Let's start there.
Oh, good question. Email marketing API, basically, right? So you can send emails on somebody's behalf.
So maybe it's like which email address you can send from?
Yeah, the domain, because in SendGrid, MailChimp, you validate certain domains. And so if an attacker has access to a key that can send domain or emails on behalf of your organization's domain, that's probably pretty bad.
Maybe I care if it's from my company, but I don't care if it's like a random domain.
Yes, or a test domain, or yeah, exactly.
Makes sense.
And then one other example of like what a resource is SQL servers. Like what do you think is most valuable in a SQL database?
Oh, geez. Well, I'll tell you, what I've seen a million times as a bug bounty reporter, that if they have the ability to query that database, they're just going to download all the data, and we don't want that. So I think if there were a way to tell what's in the database, but without actually pulling the data, like the name of the table or something like that.
Yeah, exactly. It's like the metadata, like the table's name, what database it's in, as well as like maybe how many rows of like megabytes or whatever, rows of data there are. That type of information.
Makes sense. So like if it's 37 terabytes, maybe when that developer says it's just a test key, we got to take a closer look.
Might be production, yeah. And so to actually get this data usually is pretty easy. Like the permissions is really hard and annoying. This is usually pretty straightforward. There's usually an endpoint you can query to get this data, but not always. There's always going to be an exception. So like NPM, for example, their API isn't super well documented, which is understandable. I feel like a lot of people don't use their API, but there's no, that I know of, clean endpoint to query for this token. What packages can this token update or write to? And so in those situations, you need to get the universe of packages that you think they could update and then test one by one to see if they can.
And these NPM tokens can publish, right? They can write code to these packages. So this is like a serious question we need the answer to. Like what packages can this token backdoor?
Yeah.
And they don't have an easy way for us to answer it.
It's not an easy answer. And so all of that was the methodology. And so we put a lot of time into doing that manually for many different key types. And so we packaged it as Trufflehog Analyze, and I think like the one sentence of what it is it's just a command line tool that implements that. It helps you go from a API key that is just some string in some code or a Slack message or wherever it's found, and be able to just from that discover the permissions, resources, and ownership information from that key.
Well, can we see it in action?
I would say we should. Okay, so this is an example from GitHub. So I'm creating it's big enough. A classic token. I'm giving it 3 permissions: repo, read SSH signing key, and read another key that I forget that I ran in there. When you run this, and I'll pause in a second here, but the idea is Trufflehog Analyze is built into Trufflehog. So if you've ever used Trufflehog, you just run Trufflehog space analyze. And then we specifically ask users to pass in the keys, not on the command line, because we don't want folks putting a lot of credentials in their bash history by accident. So you pass it in this little terminal user interface, and then this is kind of what spits out, is we give you information about, in this case for GitHub, we do the scopes that it has, the user, how long the key's valid for, the type of key, and then down at the bottom what repos it can access, meaning like what resources. But there's a second GitHub example that I thought would be interesting to look at. So GitHub has a feature called Code Spaces. I don't know if anybody's used it before, but basically it's an in-browser VS Code editor. And the idea is you can make changes to your code base, push it right away.
So this is like when Microsoft bought them and they just pushed VS Code right into GitHub as fast as they possibly could.
Exactly.
Makes sense.
So it's that.
All right.
But in order to make changes, you probably need some permissions, right? Makes sense. So I was kind of curious, and I looked in the environment variables here. And if you grep for GitHub, sure enough, there's a token there. It's prefixed with GHU. That's a token that you cannot create as a user. But I was really curious. I'm like, what what is that access? Like what, I didn't give it permissions, like what permissions did it give for me? And it was pretty interesting. Once it loads, you'll see I think it's pretty interesting.
No, this is wild. Like you're using code spaces and there's this magic GitHub token that's created on your behalf. You don't know that it's there and you don't know what permissions it has. No one expects that.
Yeah, so it's by default, it gets 12 hours of permissions. It's called a user to server token. It's only scoped to the repo that code space is for, which is good. But like, look at all these permissions it has. Like I would expect you'd be able to write contents, right? Contents right, you're writing code, you want to push it, makes sense. But like, should it be able to open up a pull request, make an issue, access secrets? If I'm coding locally, I'm not opening PRs from VS Code locally. It's just not, I don't know, it's not part of my flow. Like it's kind of interesting to me that that's here, and I'm not here to comment on whether it's under or over privileged, but it's interesting to be able to quickly document the permissions.
I think it's wild this very overprivileged key is hidden in, anybody who uses VS Code all of a sudden gets these permissions. Like, no, I wouldn't expect somebody using VS Code has the ability to write GitHub issues and all these other things.
Let's look at Postgres, because I honestly think this could be a standalone tool, because personally I hate writing SQL statements, but if you're really good with SQL, then you might disagree, but the idea is, can we quickly, from a SQL connection string, understand what user it is, with what permissions, with what database, with how much access within each database? That's like, these are the questions we're trying to answer. And it's pretty easy. Like we can see the user, this user John has a couple like low-level privileges at the database or the server level. Doesn't have a ton of access, and it can really he can access one table, this queue table, and we can see how many rows of data there is. But let's contrast that with, let's say, an admin credential here, which we'll run. And these examples aren't that great because I didn't have any production databases to test this on, but this is a contrived example, obviously. But you can see that an admin has more server level privileges. They can write to more of the databases. But then also maybe there's a table that the other user couldn't access. And that's the whole idea, is just quickly surfacing really, really, really important information to know to understand how risky an exposed credential is.
And if anybody's ever worked a bug bounty and knows those triagers are really, or not triagers, submitters, are really motivated to prove impact, this is a very easy way to get the answer without actually having to download all the data.
Yeah, I think, and we can talk about this in a second, but I think this is a type of, whether it's this tool or another tool, it doesn't matter, this idea, this method should definitely be used by folks on the bug bounty side, but also the triage side, because it just cuts through so much like back and forth. And like, the fake situation with Carol and Dylan and me earlier, like those are very human interactions. We all have feelings, and to be able to remove all that and just say this actually can just access this, and that's all it is, I think it's a very important step.
Replacing the humans with robots.
That's it.
All right,
one last example. This is SendGrid, and the reason I wanted to show this example is we're going to create one token, restricted access token, and then we're going to change the permissions, but keep the same token. And so we're providing it with a few different permissions here, marketing, sender auth, tracking, mail send. So we're going to create that token, and then we're going to pass it into TruffleHog Analyze. We'll cut through me making that was just me making a fake situation as if it was hard-coded, but we all know that it can be hard-coded there. So invoke TruffleHog Analyze, pass the string in. In this case, I'm logging the HTTP request, which I'll address in a second. And then this is the output. You can see, kind of like that screenshot from before with SendGrid, it's a nice, neat little table that kind of matches more or less what you would expect in the GUI. That's the whole idea, just to make it easy to understand what the permissions are. But then let's go ahead, and I'm going to just zoom forward a little bit. Let's change the access to full access, right? So we now have changed the permissions of an existing key, and then let's run that key again. And I think this is an important use case to cover, because it has not been once or twice that I've been looking at an organization, you can see how there's more scopes here, that you update the front end saying, I want to remove a scope or two or permission, or even delete a key, but that key still stays valid, or those permissions stay valid for 12 hours, 12 weeks, on and on. It's an easy way to audit exactly kind of the interaction with the front end and back end.
Imagine you're looking at a piece of source code that has one of these keys in it. You could have the exact same source code 1 week and then the next week. And because these API providers allow you to update permissions of the key, last week it may not be a vulnerability, and this week it is a vulnerability. And like that's so unique to this specific problem. Most code security issues, you can like audit the code and kind of figure out what's going on. You just can't do that without a tool that's actually dynamically pulling the information that we need.
And so I've talked a lot, Dylan, so I'll ask you to share. So like, tell us about the supported key types.
Well, we tried to open source analyzers for key types that provided the highest impact. Trufflehog has always open sourced the widest, most wide range of key types that it can detect. It was a challenge to build an analyzer for all of them. So what we did is we just focused on the keys that leak out the most often. So initially that is 20 different key types. And this is a list that we're going to continue to maintain, grow, and open source more over time. But to start, this is a great start. It's the most commonly leaked out keys is kind of where we planted the flag with this list of 20 or so.
And so who's going to maintain all of this work? It's a lot to maintain.
Oh, I don't know.
Oh, you're not doing it?
Was it you?
Oh, I'm definitely not doing it.
Wait, I think it might be the Trufflehog team. Trufflehog team. So the Trufflehog team is going to be maintaining Trufflehog Analyze, and they're going to be continuously adding more key types and open sourcing more over time. Trufflehog is a community project. It's authored by both full-time people working on Trufflehog and a lot of people from the community. And so there's a lot of eyeballs trying to make this up-to-date, accurate, and make sure that we can actually analyze all the keys that we care about.
And I mentioned logging earlier. So the idea here is for the case of Stripe, having to send 127 requests, that's a lot of traffic to be sending to Stripe, especially if somebody's trying to respond to an exposed key. And it might be helpful, it definitely would be helpful, if you're a security analyst looking to remediate this and you're digging through logs and you want to know, was this like a white hat, like a bug bounty hunter doing this, or was this somebody on my team running Trufflehog Analyze? So we have some logs here to show what requests were sent versus the worst case, which is somebody was actually using this to some malicious end.
Joe, I'm looking at these logs, and line 4 says, no way this can exist.
And that sounds right.
What is that request?
Definitely can't exist. So that's an example of a malformed request, meaning for whatever reason, it needs a valid confirmation token, and no way this can exist for now is not valid.
Sounds like it's helpful now that I can go through those audit logs and see what all the malformed requests are that it sent.
That's the idea.
Nice.
And we've actually had some pretty good initial feedback from the community. This was maybe like a week after we launched this, somebody in the Trufflehog Slack, which everybody's welcome to join, it's an open group, said they ran it because somebody like Carol left their company, and Carol left this key exposed, and they had no way of even knowing what Slack resource it had access to. And I think the last words of their note here, help inform urgency, really speaks to what the whole goal was. It's like, let's help folks prioritize exposed secrets and understand what the risk is.
The ones that matter, the ones that are live and can access the stuff we care about.
Exactly.
That makes a lot of sense. Are there any other examples?
Yeah, so this is, I have some screenshots of interaction I had on HackerOne, excuse me, a couple months ago. And so I reported to a vulnerability disclosure program live keys on GitHub. There were 2 live keys. And they said, if you read that first paragraph, they go, this is a duplicate. Somebody already said this. I was like, well, why are they still live? But that's a different question. That was then answered with the last part, says this was closed due to lack of demonstrated impact, and after confirmation from the internal team, aka Dylan and Carol, that it's not an issue. Like this isn't just some like example we could like this really happened. But what's cool is they were like, hey, if you can provide us some impact, that'd be great. And I said, cool, I'd like to provide impact. And they said, okay, follow these rules. And I did. And then it was a valid case because now all of a sudden the triager can go to the internal team and say, I understand why you said that, but that's actually not true. There actually is some risk to our organization from having these keys out there. You must revoke them.
And not to speak anything bad of the triager, but it's just unrealistic to expect our triagers to be experts in every key type and to send 127 requests for a given key. Like there just wasn't a solution to this problem, basically.
And so if you're interested at all in checking this out, it's open source, it's free to use. If you have the latest version of Trufflehog, at the trufflesecurity/Trufflehog GitHub repo, it is just the analyze command. And that's it. Thank you all very much for attending.
Maybe we take one question, if anybody has one. Oh, there's more than one hand.
I think we probably have time for two. Do we have time for two questions?
Sorry, there's no mic, so you have to speak up.
Okay. Yes.
You mentioned NPM. They require a multi-factor now, so when you go to publish something, it says, hey, here's something like this in your browser. How is
So I'm not an expert in NPM, but I have used PyPy a little bit more, and hopefully I'm not misspeaking, but I think if you use passwords, that's a human thing, requires a human second factor of authentication. If you use API keys, it's expected a machine is the one that's going to be doing the authenticating. Machines don't have hands and phones and YubiKeys, keys, and so I don't think the API keys are actually subject to the multi-factor auth. I could be mistaken, though. Feel free to fact check me on that, but if PyPy and NPM are at all similar, I think that's the answer.
NPM made it mandatory recently.
Even for the API keys? Interesting.
That's cool. Yeah, that's a big disruption of workflow.
Yeah, how does that work for automated workflows where like CI pipelines and stuff do the...
Good question. Yeah. Yeah. Interesting. So I think for that, yeah, if we just have the key, we don't have the full key, I guess, in that case. So it's hard to actually analyze that. That's a good question.
Oh, actually, one more funny anecdote on that is while I was going through the process for PyPy to generate an API key, it did require me to put multi-factor on the account, which didn't apply to the key, but on the account. It's like you have to make this to make the API key. And part of that process, it makes you download recovery codes. And then I asked the question, has anybody ever committed their recovery codes to GitHub? I went to GitHub and I searched for that file name, and it's just filled with people that committed their multi-factor recovery codes to GitHub. So that's not it's obviously not always you're going to have the multi-factor and the thing, but I thought that was a funny story to share.
Did you have a question?
Yes. The scenario, the role-playing scenario at the beginning looked like Joe was a SOC analyst and Dylan was a developer. My role in my team is we do static analysis. So we may come across keys.
Mm-hmm.
What's your advice on when to escalate a key, when to call it a security incident?
So I think that's a great question. Like you said, you do static analysis. I don't think this is a static problem. Like I think you need to send dynamic requests to get the answer. And so that's the first thing is just like a string by itself, there's no way to know. Like you have to send some dynamic requests to get some more answers to those basic questions. Prior to this, people were prioritizing based on type. But the problem with that is like imagine an AWS key that has no policy attached to it. It's like it could be the worst thing in the universe or it could be literally nothing at all. And so like to answer your question, like how do we prioritize? This is why we built the tool. Basically to figure out whose key it is, what it has access to, and what permissions it has. And then based on that is the only way that we're going to be able to prioritize and figure out which things need to be worked on.
Yeah, that's what I thought the message was. You can't triage it without dynamic analysis. So
Yep.
we either need that capability or we need to refer to some case to someone who does. Thank you.
Mm-hmm.
Yeah, so is tuple of analyze trying to reduce the permission of the keys? Or, for example, like if Carol has stayed in the organization and you have contacted her, her key has been leaked in a code and you have checked the permissions. So what, she instead rotated the key, removed it from the code and stored it in a vault. She did not change the permissions. So the problem still exists, right?
Oh, that's a great question. I mean, trouble log analyze doesn't have to just be used on leaked keys. You could use it to analyze your vaulted keys and then look at the permissions they have and then use that to reduce your privilege within Vault. But yeah, like there's a lot of times where keys may have full access to something and it may not need full access. The application may not need full access. You're never going to be able to know that unless you have some tool that can actually tell you what those permissions are. There was a use case where I remember there was an incident that happened because a key got revoked and a production service, depending on it, stopped working. SRE got paged at like 3 o'clock in the morning. That SRE had no idea what permissions that key was supposed to have, and they just wanted to go back to bed. So of course they just replaced it with full access to everything. We need tools to be able to tell us what those base sets of permissions are, and this is the first one that we know of that can actually start to answer that question. So you can run truffle log analyze on keys that are vaulted, and then use that to generate what the permissions are of those keys, and then start that conversation of if that's too many and whether or not you should reduce that.
So basically, a person who wants to use tuple or analyze should have access to all the walls and all the keys and stuff like that.
Well, it has multiple use cases. One use case is if the key leaks out, we can answer the question. Another use case is if it's vaulted and we just want to reduce the access, then we can answer that question. So kind of depends what your use case is. But if you're trying to reduce the access for your vaulted keys, yeah, you're going to need access to your vault to be able to do that.
Do you have to establish like a baseline of keys to understand if the server side is to change the permissions, you wouldn't end up with like a regression? So do you keep like all the keys that you have to keep your testing against?
Yeah, so like if basically it's a type of key that permissions can change over time.
Yeah.
Yeah, that is a good question. Like that's like one of the examples that we gave, I think it was SendGrid, where not all API keys can have their permissions change over time, but some of them can. Again, it's just kind of speaks to why this problem is so challenging. You might look at it this week and it can't do anything, and then next week it was getting extra privilege. You have to just keep running analyze on it until it actually gets revoked and move over, because it could change over time. And then you may have a bug bounty reporter that submits something, and then the answer is, oh, it doesn't have any access. And then next month, another one submits it and says it has full access because it changed.
Yep, I think maybe last question. Yeah. Okay.
So yeah, thank you so much for this. I think this is a great way to actually triage some of our secrets. My question is more about the industry, right? Like you showed us how the finite access looks like. Doesn't seem like a great solution of how we maintain secrets today, or just one key for all, right? Like that isn't a great method either. Are there, as you folks have had customers or people who have been using these tools, have you seen some company change their strategy about like, how do we actually use secrets? Because I don't think 127 ways is scalable to finite access, or like having one key for every kind of action. Great, it's like least privilege, but is it really right size, right? Like, have you folks seen anything in the industry changing with respect to how we use secret management?
That's a really good question. I think it's kind of like a privilege question, or like an identity access management question of like, why is it so easy to make things with so much privilege, or like, why is this so unstandardized and hodgepodge? I remember I talked to somebody that was working at Google a few years ago who was on their IAM team. And I asked them, why is it that when I make a default thing in Google, it gets 9,000 permissions? Like in AWS, you make a VM and it defaults to nothing. And in Google, it defaults to a role that has 9,000 permissions. Why is that? And the answer that they gave me is because in AWS, you get nothing. Like they wanted developers to be able to use their platform easier. They wanted somebody to be able to spin up a VM and then I could just directly talk to a database. And so I think we're a long way away from the whole industry saying we're going to scope our access down and everything's going to default to secure. And that kind of just leaves tools like Trufflehog to clean up the radioactive waste that these large tech companies are defaulting to most privilege.
Cool. All right. Thank you, everyone. Appreciate it.